Hey everyone, and welcome back for part 2 of your first week of review for your exam. I noticed that Sherry sent you all a reminder saying that the final exam has been moved to Monday, April 27th, and it's going to be a similar format as midterm 3. So if you have questions or the formatting of midterm 3, let's make sure we get those worked out before you take the final, but similar process for it. But know that there will be more questions, so it will take you longer. It is still a final exam, and your final exam time slot is obviously a lot longer than your midterm time slot, so be prepared for that. And another reminder here, there's no more quizzes or homework because you're done with the material for this course, but these materials will be great study materials, and there's also going to be a plan rolling out for ODI tutoring next weekend, so stay tuned on that. And I will be available, I believe, on Sunday. So let me know if you have any questions, and we'll go from there. This video is not going to be as long as the other ones. As you noticed, Sherry's notes were a little shorter for this one. So let's start with 9.1, systems of equations in two variables. And in the question, I've asked you to solve this question, this first one here, with substitution. So on the exam, you'll be able to use whatever method you prefer unless it's indicated. So it is important to be comfortable using substitution and the addition or elimination method. So keep that in mind. And once again, just a quick reminder to do the problems I'm sending you first before doing this, as it will make a lot more sense for you. So a substitution, we want to make sure that each of them, we can solve for one of these variables, but it's pretty easy to see here that we don't even have an x, so it'd be pretty easy to solve for our y. So we're going to set y equal to negative 18 minus 6 all over 4, which means y is equal to negative 6. So now we can just go ahead and plug this in to this up here. So we get 3x plus 12 equals 33. So when we subtract that 12, we are left with 21. So x equals 7. Now I want to put our answer, sorry, that was bad. Put our answer in a set notation. So we'll go ahead and do our x coordinate before we do our y. So then we're going to go ahead and solve this one a little differently. We're going to try to eliminate. So to do elimination or addition, we have to get rid of a variable. So in this case, I'm going to multiply that by 3. This whole top row then becomes 9a plus 6b equals 15. And then I can just carry over the second row. I see my a's cancel out because I'm adding these rows together. Whoop. Where'd we go? There we go. So then, when we combine the b's together, we have negative b equals 8. So b equals negative 8. And then we just need to plug in our b into one of these equations over here. And that's just a personal preference. You can do whichever is easiest for you. You're going to get the same answer either way. So I'm going to do 3a plus 2 times negative 8 equals 5. So I get 3a minus 16 equals 5 plus 16 plus 16, 3a equals 21. A equals 7. So A comma B looks as so. So then, all right, so when we move here to 9.2, we're looking at systems of equations in 3 variables. And oftentimes you'll see in the questions and the way they're asked, they're never really probably going to specify what method you need to use to solve them, because it's probably going to take a combination of both, or at least attempting both in order to get somewhere. So, where are we going to begin here? My recommendation is going to be to work with these z's in some capacity, because this is a 2. But we have row 1, row 2, row 3. And row 3, z's can easily cancel out. So let's start there. And let's rewrite them over here. I'm going to write my z's in that way so that they don't get confused with 2's. Then these cancel out when I add the rows together. And I'm left with negative x plus y equals 3. Now, I'm going to go ahead and take row 2 and row 3. And I'm going to multiply row 3 by 2 so that I have the same number of z's to cancel out. So rewrite row 2 as is. And then I'm going to multiply that whole row, row 3 by 2. Then I'm going to add the rows together. So I get 7x minus 8y equals negative 25. And because I have these here, I can go ahead and choose to eliminate a variable because I have the same 2 variables there. Or I can just solve for one variable. So I'm going to say y is equal to 3 plus x. And I'm going to go ahead and plug that in into this equation over here. So when I distribute that, I get combine my x's, and I'm going to add 24 to that side to get negative 1. X equals 1. And now I can go back to here and find that y equals 3 plus 1. So y equals 4. And now all I need to do is go back to an equation that had the z in it to plug in my x and y values. So I have gonna go up to this first one here. Plug in 1 for my x, 4 for my y, and leave z is what I need to find. So I see negative 3 plus 12 minus z equals 5. So I'm left with negative z equals negative 4. So z equals 4. And I need to again put that in the same notation as I did for my other 2 variable equations. So 1, 4, and 4. Now, for 3 equation systems like this that you're trying to solve, it's not always going to be clear as where to start, but you have to start somewhere. And you might think what you're doing is going to work, and then you might realize that it doesn't. So the second one I've chosen here to go over with you is one of those. There's a couple options where I could start. It wouldn't be too bad to start with trying to cancel my y's, but you have to multiply. So my reasonable option seems to go with row 1, row 2, row 3, and start with row 1 and row 2 to get rid of my z's again. Now when I combine these rows, my z's cancel. Now it's a 2x plus 9y equals -1. Now, since I'm solving, getting rid of my z's, it makes sense to somehow incorporate this z. So I'm going to take row 1 and row 3 and multiply row 3 by 2. So my row 1 I can copy, and I will get 6x plus 10y minus 2z equals -2. And then to multiply row 3 by 2, I will get -6x minus 10y plus 2z equals 0. So when I do this, I see these all canceled, but I have to add these together. So I'm left with a 0 on this side and -2. This is a false statement. That tells me there's no solution. When you get to this point where you get a false statement, that's your cue to just